fracture detection using radon transform. He is consulted as a subject matter expert to vet the technology stack of various startups. The topic for this session is writing queries in Neo4j. I request Mr. Akashdeep sir to please take the session.
Thank you, ma'am, for your kind words. I'll just get the screen share started. Thank you. So, if you lose audio, please tell me, and I'll just go ahead with this brief about why Neo4j. So, previous speaker has given some hint. Okay. What I want your attention to be focused on is that, see, you may know that you know something. Okay, so let us put that in the category you know. Then there are so many other things about life that you already know you don't know. But there's a third category. I will write it here in the corner, but to, just to put some like figure, like you may know that you know SQL databases, or you know that let's say
There
your
are
in
some
whatever you
basic
had
use
studied, and
cases
then
of
subsequently all
Neo4j.
the way up to PhD, you know all these things, and then you know that you need to know more about graph detection or other
Yes,
areas that
sir.
you already know. Like some of you might want to learn a new language. Yes, is anybody tell?
So we know about the
Is
basic
it clear
use
now?
cases right now. Basic use cases like
Huh?
it's used for
Yes, yes.
recommendation
I'm
system.
bringing your attention to something else. So you know about the things that you don't know. That is another category. Where graph databases excel is in knowledge discovery, particularly things you don't even know you don't know. If I tell you, tell me something that you don't even know you don't know, can you tell me some answers? So see, that's the point. You either know or you don't know. But the things that you don't even know you don't know, we can't really give answers about it. And that is the blind spot that all organizations are facing. So one of the ways to address this blind spot is to keep bringing in new talent and doing R&D and then having consultants on board. That is one traditional approach. But what about all the information and manpower and the subsequent human capital that already an organization has with itself? So that is like where you can really cause some
Your
cross
screen is not
pollination
visible.
and new discoveries to be found. Sorry, did somebody ask something?
Your screen is not visible.
It's not. uh, okay. So
Yes, sir, now it's visible.
so one of the approaches that Amazon was steering is to create a data lake. And what is the data lake all about? It can be different departments, vendors, okay, all the kinds of transactional emails that are going out. Every time you buy something from Amazon, you get a bunch of transactional emails. Or if you abandon your cart, then also you get a bunch of reminders. So all of this information started to come together, but still the main problem is that the rate at which the data is growing is still, not manageable for the data scientist teams to understand what to particularly innovate, and what is the problem of the user which will be scalable. So what the graph databases allow us to do is that they allow us to discover knowledge that we didn't know, just by traversing randomly across, or by selecting certain nodes and looking deeply into it. So I'll just go through this. So you've seen some of the queries, okay? So if you want to, let's say, find out who is talking, then you can put this whole thing in this form, right? You can make a speaker, uh, and then you can give the property, the key value, and so on. So you can create these kinds of simple nodes. So that knowledge graph and the discovery of things that we don't even know, that appeals to a lot of businesses. Particularly, you will find that, you know all the major top financial firms, top software firms, as an ecosystem, it has been uh, embraced by many players. And these are to show just a few of them. So let's say there's this chart, there's number of supplies and type of school supplies. Typically, we would tabulate this, and we would, for small data sets, it's okay to tabulate. But then, as I said, in the case of a data lake, the information is exploding. So the graph allows us to mine and see stuff that we didn't expect. I heard a question about fraud. So in the case of fraud, I have a slide, I'll get back to it. But just keep in mind that traditional graph theory, what is called as a vertex, it will be represented as nodes, links and edges, they are represented as relationships, and properties and labels. So properties and labels are something that Neo4j has brought forth. And in the cipher query syntax, which is open source, it has been adopted, and you'll find equivalent things in any other graph database also. So here are some of the people, the Panama Papers, they always get a mention whenever Neo4j is mentioned. Okay, so just one law firm leak suddenly started to, bring to attention so many celebrities and powerful people into the limelight. This wouldn't happen if we just had traditional databases. So in traditional databases, it's easy to mask identities because we are not really able to sense the interlinkages. However, using Neo4j, even journalists and of course their different technology teams were able to see what are the pseudonyms and numbered accounts that are continually having common connections, or different you'll see all those different graph properties that will start emerging out only when visualized as a graph. And similarly for NASA, it's important to see what are the different celestial bodies that are continually in motion. So how many times will you do a join when there are like hundreds of billions of moving asteroids and similar such celestial bodies? The join operation itself, by that time the body would have completely gone out of the predicted trajectory. So that's just forget the celestial bodies, just to see whether all the satellites that are in our orbit don't end up crashing with each other. That itself requires a lot of orbital paths to be mapped and then understood, so on and so forth. Now, why in AI? So many of you must have seen that back propagation and how deep neural networks have leveraged graphics cards, and they've generated some remarkable results, and it's exploded like anything. Still, explaining why a model is picking certain characteristics is still a big issue. A lot of times, for to give an example, giving a training of two breeds, fox versus wild, I mean, not exactly wild, but raccoon dogs and similar other dogs which have ancestry to fox. Half the time, the neural network ends up distinguishing based on the color of the background, even now. So is it possible to use graph traversal instead of just back propagation, graph propagation? And that is a huge research topic. So the world is a graph. All of us in this call, we have been connected and we have all been tagged as nodes in Google's graph. Whatever we are speaking, whether we get the caption or not, Google is captioning us. That is the world we live in. So why not, sensitize ourselves? So to keep it back to the topic, we know there are nodes in graphs, then they can be labeled. So these three nodes, they can have multiple relationships. For current use case, let's say these two people have the following relationships, as you can see. Now to relationships, we can add the key value pair, which is property. I'm guessing that Gran Prakash sir has already covered this. So I'll just move quickly through this. Now the use cases. So fraud detection, anti-money laundering, e-commerce fraud, first-party bank fraud, insurance fraud, link analysis. So the use cases keep adding up. And by now, if we go to that URL, you'll find even more use cases. Real-time analysis of data relationships is essential to uncovering fraud rings and other sophisticated scams before fraudsters and criminals cause lasting damage. So all of this is there, but still there are cases like the Archegos, multi-billion-dollar situation that emerged. So what happened is three large banks, JP Morgan and two others, they both had lended to one party, but they each behave like we don't want to tell each other how much we have lent. And then that party went and invested and the investment tanked. Now usually there are risk management metrics, but when the party has placed a significantly large multi-billion-dollar deposit, then the risk metric is waived off. Had they interchanged that, see, we are making risky trades along these particular asset classes which this fellow was trading, then they all would have saved themselves from a massive multi-billion-dollar loss. But that's pretty much the reason why a lot of frauds happen, because the information is just not made available to each other on a basis where you can see in real time what kind of misappropriation is happening. So this was the Archegos case. You can find it still pretty easy to search on various news platforms. So even though it doesn't come together as fraud, but actually it is almost fraudulent. So what if you have a lot of money if you're going to be doing obviously risky, crazy trades and burning a whole bunch of taxpayer savings, because these banks now they are getting some kind of backdoor bailouts from the American government, which is again impacting the taxpayer. So we are all interlinked. Even if we think that we are so far away, more than 6 days of connection away from the billionaires, their impact on society is affecting all of us. Anyway, so use cases. We've seen fraud detection, then there's master data management. So organizing who gets how much access to your data is a perennial burning problem. If you give too much access to an employee and then that employee jumps ship, then it's likely that you could, or even just starts their own startup. So then you've given away your client list to them. So how can you figure out what is the appropriate amount of data that each employee needs to get access to? One of the ways is to see the access patterns. So in all the NoSQL databases, we might get lulled into thinking that there is no schema. That is true as long as the language syntax is concerned. But for all kinds of investments or even any kind of practical business application, access pattern and the entity relationship diagram still plays a huge role. Depending on how your users are querying your data set, database, and what recommendations you need to give so that they stay on board your platform will have a huge impact on valuation. Similarly, if you can figure out what kind of access pattern your employees need, okay, here your employees, they are also accessing data. This could be one, two, and it could be tens of thousands. So the access pattern matters. No schema is syntactically right, but actually in practice, you still have to see the access pattern and you have to make sure that it is delivering on the business promises. So let's say the recommendation engine, which I was getting started to. I'll give a personal example. I closed my Netflix subscription. So I'm majorly into investing, okay? And anything that is related to any upcoming technology, one of the cool places to see is documentary. All the latest cutting edge science you can see in simple language, and you can then start looking at which startups are working on that. That's one early way to gauge where the disruption is coming next. And every time I log into Netflix, even though they've seen I've only been looking at Netflix documentaries, they'll still flood me with all the movies and all the other content that they've got access to, which is probably getting them more returns. So ultimately, I went and closed my Netflix subscription. So similar things can happen if you give the wrong recommendation too often, or you keep making your user go through too many hoops to get to what they need. You end up risking losing the user, customer, subscriber, so on and so forth. So that is one example from my end. Then graph edit search engines. So graph edit search engines, product recommendations, so on and so forth, social recommendations. So anybody in your circle in LinkedIn who has 20 or more common connections, I've seen this myself. And even if the person doesn't know you personally or anything, they will not even check the profile of yourself. They just accept your request. Try yourself. So there's one more thing. Then another use case is knowledge graph. So that's what I was telling you earlier. Discovering things that we didn't even know we don't know. Asset management, cataloging, content management, inventory, workflow processes. There's so many places to put knowledge graph, provided you are generating that much knowledge. So tap into the power of graph-based search tools for better digital asset management, and so on. So use cases. Infrastructure monitoring. So everything is now remote as far as possible, including the restaurants in Silicon Valley now are using robots to cook food. And the same trend is pretty much getting funded in India also, whether it is a dosa maker or so on and so forth, including you can make a fried rice using a machine. So if you get that kind of a scalable backend, it's possible to start cooking food anywhere where you get access to electricity and fuel. Even if the person might get a heat stroke in that desert or windy area or very cold area, the robots can still work. So then you only need to look at the customer service end and have your serving staff be adequately equipped for that region. So one of the things is these kinds of assets that are remote, and this data logging system, it's pretty much old. It's there since like 30-40 years. Data logging has been happening, but then how to take advantage of that data and start in real time understanding the reduction in demand. So recently I saw that Hero Motors has stopped production across several plants. They've done this and they've seen that the impact is going to be there, so they decided first let's just all the existing inventory get used up, so on and so forth. Different initiatives you might have to take. So the Toyota company and the other Japanese, they were one of the first to start uh, so many other customer facing processes, such as total quality management and like all those other reliability and quality engineering and Six Sigma and all that. And that was a competitive advantage for a whole decade. Every Japanese car was outperforming the maintenance costs of all the other cars. So there they were managing the infrastructure so tightly, but now that itself is not enough to be a competitive advantage, because there are so many variations in the engine itself. There are electric engines, and it's not going to be happening all in Japan as it used to be earlier. So you have to depend on different work cultures to deliver the same values of the business. So infrastructure monitoring has become even more important than before. Social media and network graphs. So community cluster analysis, friend of friends, recommendations, influencer analysis, and so on and so forth. Very important if you're using a good social network thing. So easily leveraging social connections based on the activity when you use a graph database to power your social network applications. So this is a place where graph databases shine. So artificial intelligence and machine learning. This I had previously mentioned how it is like graph-based systems are creating a revolution in understanding the explainability of what a model is under, like giving weights to. So what is the features that the neural network is holding on to. So Neo4j database typical characteristics and so on and so forth. So there's one big difference that I would like to highlight why all these NoSQL databases have emerged. So when SQL like databases were there, that time compute was cheaper than storage. Now is the other way around. Not only SQL databases, here we see that compute has become the bottleneck. Whereas whether you want in memory, that is RAM, you can get distributed systems from Azure and all the other cloud providers in different capacities up to 12 terabytes. So you can have tremendously huge graphs in the memory itself. And you can also get lots of storage. You can get so many terabytes. It's practically possible to get whatever petabyte quantity you want. That was not the case when the SQL database first emerged, RDBS. Anyway, so Neo4j is a graph database, and they have a huge ecosystem. They have a developer workbench, special tools for graph visualization, cipher query language, which we'll be soon getting into. So here it is saying free and optionally schema based. So once you start constraining, then you start putting your own schema. So here are some of the key differentiators. There's index free adjacency, and data is connected and as it is stored. So the connection lines are where the graph is giving, like Neo4j culture is giving a lot of thrust. Okay, so it is able to retrieve data very quickly, and graph value is found in traversals and hops. So this is one of the other ways to look at the graph storage, how something is coming in and coming out. So node store, how it relates to the relationship store and to the property store, and then what are the input output loops. So practically in this diagram you can take a simple understanding that most of the tables you can convert into graphs. Like this row will be represented in this graph. Similarly, other nodes and similar clusters you can convert from a next row, and so on and so forth. Casual clustering. So these are different kinds of algorithms. This is the GitHub page. You see if this is useful for your research. Okay. So there are multiple different algorithms that are available, and APOC is the main library where you'll find a lot of traditional graph theory algorithms implemented already in various performance levels. Okay. So node property existence, relationship property, unique property, node and combined properties. Okay. All these you can set. So very basic. Okay. Create, and then you start giving in the details. Label followed by property, then followed by relationship, and followed by node, next node. So this is a directional relationship. Okay, you can have it, and then if you want to know what it has created, then you have to use the match clause and then the return clause. The Neo4j browser projects different ways in which you can access different apps that you've connected. So natural language search is a big deal. Full text search, graph patterns, custom search phrases. So and the perspective. So business view of the graph, departmental views, yeah, styling and so forth. GPU accelerated visualization. In the world of 2021, GPUs are so much in demand that whatever GPUs were selling in 2018, they're practically 3 times pricier now, particularly AMD GPUs. What with all that distributed ledger and cryptocurrency and all that. So GPUs have become really the driving force in which new discoveries are happening. One of the reasons why mRNA vaccines were developed so fast is because of the accelerated use of GPUs. So direct graph interactions, select, expand, dismiss, find different paths, exploration, so on and so forth. A lot of things are possible. So if you go to the URL for Neo4j sandbox, you'll be able to see so many other data sets. This may or may not be downloadable. Okay, some will, some won't. You'll have to see what is the case by case basis. Okay, graph analytics. Local to global. Okay, zooming in and zooming out. This is what I was telling. You know what you're looking for and making a decision. You're learning the overall structure when you're looking at the big picture of a network, updating data and predicting. So here's the thing, whenever any fraudulent activity is happening, typically, okay, there's a case, I have a slide for that, I'll get back to it. Predict and prescribe. So there are different propagation pathways, the flows and dynamics, interactions and resiliency. So complex emerging behavior. Complex and emerging behavior, you can get the better understanding through relationships and structures in the form of a graph. So what is propagation pathway? This is the thing that all e-commerce companies are running. How to get the goods delivered in the shortest amount of time. Amazon Prime. So planning and least cost routing with flow dynamics. Okay, routing engine, basic features, switches. Okay, these are all examples. This may not be applicable obviously for your use case depending on what current tariffs are going on. Different numbers will be there. But the thing is, all these things will come together when you want to cause a single e-commerce transaction. There will be a delivery guy. He will be calling the person who wants to receive the articles or deliverables and see if they are not available, what to do with the delivery, so on and so forth. So all these things, they can be also mapped in the graph. Group resiliency, bridge points, and like language telecom network. This is one of the use cases. You can also look into this archive link here and go further into the detail on how telecom power outages, in spite of that, how they can load balance the call frequency and so on. So there are so many kinds of graph algorithms, and they've been elaborately explained in this book with a lot of code examples. This is the go-to book, 2019, relatively recent. And then the next best place is the neo4j.com website. Pathfinding and search. Single source shortest path is going to calculate the shortest path between a node and all the other nodes. All pair shortest path finds all the shortest paths between all the nodes. Whenever you use all every time, then that path isn't exactly as short as a single source path. But that is also necessary when you want to create a delivery across multiple touch points. And that's pretty much how Amazon deliveries happen. Even if you have ordered articles on the same day, their deliveries oftentimes are optimized in a way that maximum other deliveries are also happening in the same fuel expense or same path. I think one of the ways in which, especially for e-commerce, different UIs are developed. Here, I would like to bring your attention to how JavaScript and all is used to continually keep updating the real-time information. Centrality algorithms. Degree. So the number of connections. So A has a high degree. Then betweenness. So which node has the most control over flow between nodes and groups? So C is a bridge. Without the C, all the people in this network, they're going to have a hard time traversing to other networks. Closeness.
Sir, sorry to interrupt. Can we
What
calculate
is
between,
a node which has the?
sir, can we calculate
Anybody saying
betweenness
something?
through Neo4j, or we need
What?
to do mathematical calculations? Can we calculate
Math.
betweenness?
You can do most of the trigonometric and other math operations. Is that what you're asking?
Sir,
And
do
then you can use them
Neo4j
for your
provide the tool? Sir,
closeness and all these algorithms.
I'm asking, do Neo4j provide a tool for computation, or we need to calculate mathematically only?
By tool, you mean what exactly? It's already in the language documentation, all these math operations.
Okay, sir.
Okay. So then page rank, the thing that made Google super famous. Which node is the most important? So D is foremost based on number and weighting of in links. E is next due to the influence of D's link. Here's the thing. In today's day and age, everybody is trying to game this property or this trait of page rank. By game, I mean they're creating machine generated blogs and then they're backlinking. So then what Google is doing is it is one upping its knowledge graph. All of us with Android phones, or any other phone also, as long as it has a Gmail app in it. Google is using our geolocation also, and seeing, giving us, trying to give us location based results. So PageRank in the age of location is a whole new degree of sophistication. Try and see this for yourself. With just install a VPN and see the search results. The ads will differ, and suddenly all those sticky ads that were bothering you they will also go away. Just keep hopping your VPN. That's one of the ways. Anyway, so there are a lot of notable papers here. This is one of them. Ranking spaces for predicting human movement in urban environment, and how to fight toxic waste with Google PageRank. There are some of the Wired article and so on. Similarity algorithms. So how alike are nodes, and at the individual level, properties or attributes. So these kind of similarity matches our jeevansate.com and all the matrimonial sites they are trying to run all the time. That is why they will ask us hundreds of questions. Community detection algorithms. So this will tell us how a group is clustered or partitioned. Different approaches to define a community. So here you can see label propagation prediction. Okay, this is on Neo4j website itself. Then Twitter polarity classification. This is on ACM. Link prediction. So can we infer which new interactions are likely to occur in the future? And then formalizing the question as a link prediction and developing approaches to link prediction. Proximity of nodes in a network. This is done by Kleinberg and Liebenauer. Okay, I'm just going to go into Cypher now. Let me put this aside. Can somebody tell me the time? It's 1 o'clock. Okay.
Sir, half an hour is still left.
Okay. So I have a lot of Cypher cases, but okay, I'll go with this one. Let's see. So you were asking for operators. So let's see, one of the operator. So you can create nodes using this query, and you can match the nodes. Okay. Now we'll see how the operator is run. So you have your node. This node was created so that we can see the demo of the operator. Let me just go to the next slide. Earlier I had deleted that. Okay, so AND operator. So you type match employee, where you're giving the name label, you're creating, and you're looking up this user Satish, and a salary. So the AND will help you to narrow down. There will be many employees with many different salaries, but once you start using that AND operator, you'll find the requisite node. Yeah, this is one example of AND operator. So next one. So similarly, you have OR operator. Okay. So you can look up different members of the same organization. If you have created the node, it will show up. Okay. Then connected data. So what does different connected data need? You need relationship. So how to make the relationship? So one of the things is you match and look up the nodes, and then you know department is another node here. Okay. So department name is scope for this example, and then you start creating the relationship. Create is the keyword. Then you use this dash with an this square brackets. Works for is the relationship, and you give a dash with a arrow, and you will make it like this. Then you mention the other nodes. So Satish works for scope. That is the thing. And then anything you want to see, you always have to put the return clause. So W is a relationship. So that is why you have to ask it to return that also. And you will get the return clause where it will show the relationship works for. Okay. Let's move on to the next. So, yeah, let's see one more. So there is scope department, and then you are connecting it with RAM. Earlier it was Satish. If you don't put the return clause, then it won't come. And so we have connected them in this way. So what is managed by RAM? So let's see. So you put this query, okay. Match employee name RAM manages, but you need to have created these nodes first. So yeah, department re- return the all the things. Yeah, and it will show what is managed by RAM. So here RAM is managing two departments. Relationship properties. So different relationships. Employee name works for department, name of the department. One of the ways. Then you set. Once you say use the set command, you can give your desired relationship or other updation you can do. So you can say this relationship in addition to works for, you can also give the property joined date, and then you have to return all the things that you're putting here. So notice for that property, we don't have to again call it. Okay. So when you scroll down, you can see the new relationship, joined it. Similarly, if you want to delete a relationship, you can match, fetch the node you want to work on. And relationship works for department name. So here, what happened is, instead of the employee name, I type the department name. So we need to be careful. Then delete what you want. So now SBST and RAM have no relationship. They're separate nodes. So similarly, let's create some more nodes. You can use this create clause. Okay. Let's see. What you have created, let's match. Relationship is drives. Written E and relationship and D. Okay. Next, you can also delete the relationship. So right. So if you want to delete, you have to make sure that there are no relationship. And if there are relationships, then we need to detach them. So match and delete n should give us an error. Okay. So it's one of the inbuilt constraints. So to go about it is using detach clause. Delete n, and before that, oh yeah, if you don't put detach, it will again give error. So match and detach, and then we can give delete. So then we'll get all this. We'll get a deleted result. So we can also just delete the relationship. Match E, fetch the node, then so here you see delete R. So you have to mention what you want to. Of the many relationships, mention the one you want to delete. Here there are not many relationships, but in many use cases you will see many relationships. Okay. Um, for one query for full path, can you do that? So match and delete n is to remove the earlier nodes. Let's create some nodes. Create employee node. Give the property name Chris. Connected.
Meeting is full, so kindly a few people leave the meeting so that the speaker can join again.
उनका लगा नहीं होगा ना क्या बोलना कि देखोगे
Few people kindly leave this link and join at link 2 so that the speaker can join again.
Am I
Yes, sir.
audible?
Yes, sir, yours audible.
Can you see me?
Yes, sir, your screen is visible.
Okay, okay. It just dropped off and then it started telling me meeting is full. So I closed my one of the screens. Okay. So query for full path. You create your node, then name your node, give the key value pair, then it works for in the scope department. Okay. Then going back to the start. Wait. Here you can see you have to in the same if you want them to be directed to the same department, then you use the opposite of the earlier arrow after the name of the department. Then you have to again mention the relationship, but the relationship it should not be having the same W. You need to give it W1, and the employee also cannot have the same E. It has to be E1. So when you can in the same line you can give a complete path. Path is in the path in the graph. You can put multiple nodes and relationships in one line. And for return, you have to again mention each of the new things which you have created. I mentioned. Otherwise, those nodes will not be returned. So here you can see Chris, Jeff. They both work for scope department. So one more scenario. Let's see. So they are working for this department. Then let's detach and delete some of them, all of them actually. And after deleting them, we'll create. Okay. So we'll create again. The idea is you give the name and all that. What we are trying is something different here. Okay. It works for and all we are putting. And we are trying to see if you want to put a manages for also relationship, different kind of relationship. Okay. So let's see. Somebody works for also and manages also that department. That's what we are trying to create. Employee 2 named Tom. He manages SBST. Satish also manages the same department, SBST. So will we get the output? Let's see. So we are going to call all the nodes and relationships that we want to see in the output. Let's see that. So it is saying we got an error. Create line directed relationships are only supported. So the relationships between Manage and Satish and others are having to be updated. So here again give the direction to those relationships, who manages and so on. Let's see if it works. So here it is working. So in one line you can create two different relationships, but they are separate. You wanted them to be interconnected. So then if something like this happens, typically it means we have forgotten to call some nodes. There is one node that is in between that is managing also and working for also. So once you call it, it will show up. Satish. That is the one of the nodes that was not called earlier. Now that it is called, you will see it in the graph. Okay, let's go to the next scenario. Okay, this is done. Let me just look up another slide. I thought I would have not have enough time to cover it. I went to the third slide. I should have gone to the first one. Okay, I'll go to the first one now. Or better, we look at one of the ways of epoch, how to use the epoch thing to load CSV. Oh, what happened? Cancel. Not the slide I want to open. So let's say you want to query a data set. Okay, you know the GitHub link and all. In this example, the data set is not in a English language. Similarly, there can be local languages also. So go ahead and use this call epoch.load.csv function and you can give the GitHub link. I'll just see if I can put the GitHub link there. Copy, chat, link on message. It's not letting me paste. Okay, let me go inside and select the text. Oh, it's not letting me copy. Strange. Oh yeah, this is also not active. Okay, I'll see if I can send it through my desktop. Okay, rejoin. Anyway, I'll go with the demo. We'll get the slide so you can do it later. So the thing is, wherever your dataset is, okay, go ahead and use the epoch function. You can just note this down first. Okay, call epoch.load.csv, give the CSV address. Okay, this address cannot be something behind a firewall or a password or something. It can be a GitHub kind of a repository link, then it will work. Then see what are the things in your dataset that you need to call. First, you have to see the CSV before you write the with function. Okay, with name of the place. You want to give it a smaller. So all these dots and all, they have different meanings in Neo4j, right? You can use underscore, but you shouldn't use dots so much. Okay, and the more easier it is for you to name, the less mistakes you will make when you're calling that. So similarly, you can give a as source. Okay, you have to call it as source. So source is one of the clusters you're creating. So when you run the query, you'll get a huge data dump. You'll be retrieving it, so it will take time. So you'll see that it is in a kind of JSON-like format, separated and colons and all that. So now we want to convert these into nodes also. Okay. What are the recurring things that you are interested in the data? You have to take a note of those. Whether you're interested in gender, postcode, description. Okay. Then multiple fields can be the property of one particular element. That also you have to take a note of. So then let's say in this case, in the same earlier function, the line number, map, list, okay, these are all in the data set. Then you want to go ahead and put the gender also. So see, first we have taken some of them, now we are taking more of these. And then you are putting gender also. So if you forget something, then you'll have to go ahead and run the query again. And then let's see. Okay. We'll start getting different outcomes. Okay. So then let's start merging the nodes. To merge them, we can use merge function. Okay, merge is, we can use merge when you don't want the overwriting to happen. Okay. So you have to start putting the fields, okay, that you had called in earlier. You want to merge them, then you have to put the node name here. Then you have to give it a key value pair. Okay. Which is in the JSON dataset. And so on, you have to do it for each and every one of them. Okay, so map.age as age, that also we'll have to call. Okay. Because in the place name only, you can try and do this also, one of the ways. You can start giving multiple properties. As I said earlier, each node can have multiple properties also. So you can go ahead and merge the properties under the node place name. This is an example. Okay. For your dataset in your research, you might have to do different things. Instead of merging these properties under one node like this, you might have different nodes. Okay. So after merging, we start seeing some nodes. But if you don't call that return function, means nothing will show up. So this is something we'll have to get habituated. Every time we do any changes, to look up what we have done, we need to put the return function. So match A, return A, all the node that you've created will show up. This coloring can be very different for you. Okay. And you can also change the color of the nodes also. So if you just keep pressing the up arrow in your keyboard, it will go back to the prior command. Then you can go and create a new series of nodes. This is one of the geographies in that data set. We can have different geographies depending on which data set we are using. So one is the district level. He's trying to merge the district level names and so on. Then he's taking one level up in the hierarchy to province level. Okay. And very different tags in the data set. So we'll have to see and bring those tags. So see here we are calling it as PV. So then it's better to use it as PV, right? Similarly in pandas and all those Python also we say something as something. So we generally truncate it so that we can call it easily. Then we are going to start giving relationships. So what is the relationship here between A and B? That is what we'll write. So sub-district, okay. A is a sub-district of B. Similarly, there will be other relationships. B is relating to C as, and then what is the relationship, province or something? Uh, yeah, province. So a better scheming you can choose depending on your use case. This is just an example. Okay. Sub-district and all. Coming from where you are given whatever abbreviation. Okay. Using as clause, you can start abbreviating and then you can call it. So if you run that query, what you will get? More labels have been added. Okay. Earlier there were 1,000 labels, now another 341 labels have been added. Again, you have to run match A, return A if you want to see what is the outcome. So you can keep closing the other fields so that it doesn't cluster your screen much. So let's do the deletion, because sometimes in the cache the older earlier thing will be there. Then you have to rerun the merge commands. Then we'll be able to see the changes that we had done, the additional mergings that we had done with the district level and the sub-district level. So then this can happen. So just clear the cache and then run the command again. And you'll be able to see the clustering of different district-wise and other such detail-wise you can see. So you can change the colors. Go to the placeholder and from the bottom you can choose different colors. So you can change it to whatever color you like, whatever color code your organization has agreed for different clusters of information. You can even hide the nodes, so there are different options in that. Okay, you can do other operations as well. You can zoom in and zoom out and so on and so forth. Okay, so let me go back to something. Let's see. Okay, so I have to close the operation again. Okay. So relationship, we had seen how to put different arrows and we can get the relationships in the earlier case. One more revision of it. Okay. So Satish works for scope and Sam also works for scope. Now let's query it. Or maybe better, let's remove the earlier cache. Okay. But then if you don't detach, it won't let you delete. So outgoing relationships. Let me see. Or periods have we had done this? Let's see this. Aggregate functions. Okay. So aggregate functions are these count and all these similar operations. So if you do count star, it will start counting all the total. Okay. Then the answer is typically in the table format. Whatever node you had created, return count star as total employee. We'll create a table field. And let's see. Min max. So you can also use min max similar to count. If you So yeah, here you can see match E, return sum E. So you can run some operator on the node. Node is salary. So all the salaries are added together. Depending on whatever you have created, they'll be added. Then after sum, you can create other queries. So let's look up the gender. People with gender male. Can we see count star how many males are in the organization? So it will show 3 because 3 were created. Okay. You can also count and sort. So to do that, use the earlier query, and after count, we can use the order by function. Order by function will allow us to order by the count. So by default, it is giving ascending. Then we can go and after order by count, you can also describe if you want in descending, DESC. Then it will give us a descending sort. And what other ones? The constraints in Neo4j. So you can use different constraints so that forbidden operations don't happen. One of the ways of access management, definitely you need to use constraints. You need to constrain what a particular user group can do. So you got to create, let's say you're creating some nodes. Okay, an employee. Then you'll give the phone number field, let's say. So the point is, if phone numbers are not unique, then people can get away with giving the same number, kind of like a proxy attendance. Okay, so this phone number node is there. Now we're creating a constraint on said node. So e colon employee, then you give the assert the constraint. What constraint you want to assert on the phone node? Okay, e dot phone. What part of employee you want to assert the constraint? E dot phone. What is the constraint? It is unique. Simple, just like English language, we have to write e is unique with space. Then one constraint is added. Unique in action. You've seen one thing about unique. Let's see other things. So unique call db dot constraint. So most of the database like things like whether you want to impose a schema or constraint, they're all under the db dot function. By calling this, you'll get to know what constraints you had put earlier. Okay. Constraint on employee, assert employee, phone is unique, and so on. So now if you try to give it a different value, does it take it? Let's see. Employee, then inside employee, I'm going to give a phone number, and then I'm going to give the same again phone number. So I'm going to violate the constraint and see what it gives us. So yeah, it is telling us that the validation is failed. As a label, you cannot give the same value. So then if you change it,
Sir,
does
can
it
we
work?
take a break here?
Acha, okay.
Actually, we can continue at 3 o'clock.
Okay, ma'am, thank you.
Okay. Thank you so much, sir. Participants, we will be reconnecting here at 3 o'clock.
So I'll reconnect at 3 o'clock.
Okay. Thank you so much, sir.
Thank you, ma'am.
I hope all have filled up the feedback attendance form. So I will close the meeting now and we will rejoin at 3 p.m.
Okay, sir.
Thank you, sir.
Thank you.